Hello there. So I'm going to take a few minutes now to go over this question on linear modeling and a real life application of linear functions that many of you guys worked through on Thursday and expressed some desire for some support with it. So it is linked to an article. I'm not going to click the link to the article. I did that and I pulled out the important information from there. So I've already put this in my answer to number one, and so we can kind of work from there. So the relevant concept, so the vast dump of rubbish rises by 10 meters every year. That's obviously not exact, right? Like you're modeling a situation, but the information would follow a linear pathway, or a linear projection. So it's already 65 meters high and will be taller than 73 meters, than the 73-meter Taj Mahal next year, according to the report. So, and then I also wrote down that this article was written in June of 2019, because that's an important thing to think, like, what was the height and what are we measuring it from? So those are really the key pieces. And I'm just going to go ahead and type some of my answers in here, just right on this Goformative. So that's where I started with. So, and then it says select and apply an appropriate mathematical strategy to develop a model. I'm going to just write on this just because I can, and it's fun. So I'm going to rewrite some of the, there we go. So the start in 2019 was, what was that? How did I already forget, guys? Now, can I scroll up? Nope, I can't. Was it 65? I believe it was 65. Right, and then it increases 10 meters per year. So I'm going to define the variables here. So what I mean by that is, what is my independent variable and what's my dependent variable? So the independent variable is going to be the years, right? Or the years since 2019. We can get really specific here. The dependent variable is the meters or I guess I should have said this the other way around. It's the height of the rubbish. Okay, so knowing this information, what is my equation going to be? So I could have y equals, right? This is y, that's my dependent variable. So the height is going to be equivalent to 10x plus what it already was, 65. Right? This one gives you all the information where we're not really using a calculator to figure any of those pieces out. So I have my model, I've defined my variables, which are important. Okay, so now we have an equation. If we keep going with this, oh, look at, that's gonna be an interesting way for it to scroll. The type linear, I think we got that one. I didn't see any issues with that for those of us that tried it. And then sketch and label a function for the height of the rubbish mountain on on Desmos and state the suitable domain. I'm going to sketch it by hand, just because I have this screen up here, and I think it is important for us to recognize how to sketch and label. So I only really care about the first quadrant, right? I don't care about what's happened before. And I want to start it. Well, if this is the number of years since 2019, 0, this is 2019. Right? So maybe that's important for me to identify. 0 equals 2019, right? Like maybe I want a key, and then 1 year, that's 2020, 2 years, that's 2021, 2022, 2023, 2024, right? So 1 year is going to be 2020, right? And so on. So 1, 2, 3, 4, 5. I know that this should be increasing. I also know that I want it to start, I really care about that 65, right? So maybe I want to count by, I don't know, tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. I'll count by tens. I'll make that obvious. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? And I could keep going. The other piece, and I of course I need to graph it, but the other piece that's important is for me to actually label my axes. I said that my independent variable was what? It was the years since 2019, right? Indicate that. What is it? And are there units that are important to us? Our dependent variable, which I still see written up here, is the height of the rubbish mountain in meters. Okay, so now I can plot some points. So I probably want to start it at, what was it? It was at 65, so 50, 65. If it's not super clear, maybe go ahead and label it. That's 0, 65. And then I shouldn't have labeled it that way, but then it's going to go up by 10, right? So then in 1, it's going to be 75. 2, it's going to be 85. 3, it's going to be 95. Right? Maybe I'll label another one. And then we know that it's going to increase, right? That keeps going. Right? So this also asked me for the suitable domain, and I think that this is very, I feel like you could defend a few different answers here. Right? So maybe the years can really be negative if this is just indicating to me years since 2019. Right? Like maybe I want to figure out when was the 0? Maybe I do care. Maybe it's fine, like, for me to say, well, when did this rubbish tower start? I mean, I know it's in the article, but like mathematically, when was it at 0? Like that idea. Maybe we're just looking at it from 2019 on. Is there a maximum height we're letting it get to? Like, where does it become unreasonable? So your reasonable domain, like maybe I'm going to say that it's from 0 to infinity, right? Including, because I'm just going to look at the projections of it. 0, that's an infinity. My computer has some delay. Right? Maybe that's my suitable domain. Maybe I'm going to figure out, like, when was this? Sorry, what is my x-intercept? Maybe I want to take my equation of 10x plus 65 and solve it. Right? When I do that, negative 65 equals 10x. Divide by 10, negative 6.5 equals x. So 6.5 years. Yeah, I wonder if you guys can see that delay. My pen's having so much delay. 6.5 years before 2019, right? That's really what that indicates. Ooh, that's not at 2019. That's 209. Right? So 6.5 years before. So maybe it was somewhere in the middle of like 2012. Right? So maybe I want this to go from 2012 to infinity, or negative 6.5 to infinity. I think as long as you can defend it, you're fine. Like, where you don't want it to go is, I'm not going to go to some place. I'm not going to say that it's all real numbers, because the rubbish mountain isn't going underground, right? So you want it to be suitable, or you want it to be reasonable. I'm not going to graph it on Desmos, but you guys can use that as a resource if you would like. So what this then asks me is, it says, estimate the height of the rubbish mountain in 2023. So my x value, so this means that I want x to be 2023 is how many years? So this is 2019, 2020, 2021, 2022, 2023. So I'm going to use x equals 4. What's important to show here is your setup, or like your plug-in, right? So I'm going to say y equals, what was it? 10 times 4 plus 65, right? So y equals 105 meters. Right? Make sure that you're indicating the units. So, and then it asked me to justify the accuracy of your solution. And this is where you would want to go back and reference the article and see, well, it talked about what happened when it surpassed a certain height, right? Like it talked about it actually in the year 2020, like when it surpassed the height of the Taj Mahal. Like, what were they going to have to do? Like, are they going to let it get to 105 meters, right? And that's where like your application and use that like logical thinking. I'm not going to answer this question for you, but think through it and like think about what this means and what this indicates and what this compares to. And if like you need to look up what exactly is 105 meters and is it going to get to that height? Is that reasonable? Are we going to stop at some point? Like maybe that impacts your answer back here for the reasonable domain, right? Does it go to infinity? Right? And this is where you're thinking through it in the application piece of it. Let's see, what else did it ask? I'm not going to answer that question for you, but like suggest some corrective measures for waste management. You guys can have fun with that. Read through the article, and I love reading these answers. So that's where like you're kind of tying it in. There's no specific answer that I'm going to give you for that one. So that's like generally what I'm looking for with a problem like this. And I'm giving you more of like the math piece, but then think about the application. And like, I really want to emphasize with that reasonable domain and with that, does that answer make sense? Just think through it. Like, does it make sense? Is that where we're trying to go with it? And use that logic and have fun with the problem. So hopefully this clarified some of the pieces of confusion that anyone was expressing. And if it doesn't, please, please, please send me an email and we can either correspond through email. I can make another video to further explain this to you, or we can discuss this in class next week. So please reach out and continue to let me know how you're feeling about everything. Thanks, everyone.